What's up, everyone? Today I'm gonna some refactor on my code. Just gonna replace some names that I have here, and as you can see, some functions are like not well written. So I'm gonna try to make it better for reading. What I have. I think I'm gonna start with the header. This I should I think I'm gonna delete this function and initiate it somewhere else. Since these two are for the plane, I think it's better suited to be the plain file. When we create our construct here, it has to be before, because we call here. Let's see. In config, this is where the engine or the game reads the file first, these operations, where it loads the type, meaning mesh that will render, and the amount of meshes it will gonna render. I use instancing for better performance, but there is a problem for this one, because the way that I implemented it basically sends a whole bunch of information at the start of the compile. So meaning that if I want to render only 100 grasses, I send 1000 at the start when the game is compiling, and it only renders those 100 grass mesh based on the math of the player certain distance. That's not good, because the GPU still stores that information of 1000 meshes of grass. So it makes it super heavy on the view. So I will have to later where I can send dynamically 100 iterations of mesh based on my position where I am right now at plane, instead of sending those whole information at the start and bottlenecking my GPU. There's someone in chat. One yet. Don't be shy to say hi. So the first one that being rendered here, the rain, the map, and so it first is the rain where we compute our height. So this is okay. This can stay here. Next, this one, the depth frame buffer, gonna remove this and place it on the depth map file and create it here because it's more suited here. Okay, nice. The first texture, then okay. Place it from there. This. Gonna take it. Peter. Here. This is our frame buffer. Filter. Hints. Want to initialize it. Can place it. I mean, we don't need the filter right now. It's for the post-processing. We can remove it for now. It's implemented, so it just need to call it when it. Oh, okay, here it is. So we can just remove this one. So here, this is for the shadow effect, where we create our light. So instead of pointing the light from the camera to the terrain, create place, like we position our camera as being the sun looking towards us, and we project it to us. So this is what we are doing. Function look at, where we set a position and this direction. the direction moves with time. You can see here, based on the y axis. So then we create our cube projection matrix. We send the GPU, where we're gonna calculate for each shader of each mesh. Since we want to render everything from the point of view of the light, we have to create a new shader where instead of rendering normally, we render a first pass where rendered or all of the meshes within light projection matrix instead of the camera. Then on second pass we can do our normal calculation from the camera, because we want to check for the light so we can make a shadow effect. So we project rays from the light source towards the plane, towards us, and we check for each pixel that is filled within the ray, and we make a depth buffer. We use the depth from the OpenGL to detect and compute those pixels that are up front and at the back. Like we have like a mesh that is more upfront than the other. It overlaps the other one, so the other one shouldn't be rendered. So this is shadow. That's what we are doing. Since the way that I did it, instead of doing like for each frame, I did it once and can compute it based on the time. I don't know how it worked, but it does. So yeah, I place this function at the start of the game, so it runs only one time. This is what changed the skybox time. As you can see on the game CPP, here we don't compute any depth, so it only renders one time here, as you can see. Initialize our GLFW and OpenGL, then we check one time for the depth map, and we then normally render our game in a while loop, because the game needs to be rendered in a while loop. It means like a frame per frame, because we don't want our game to just open and close. We need to keep on a loop, and within those loops we can do pretty much anything based on the logic that we're implementing. Meaning that if we do a certain event with our key, it will trigger something within that frame. So let's continue our refactor. On the header, so this, you need depth map. You can put it here. This. Hold on a minute. I really don't need this one. I can just call it within this function. We're calling it initialize. So I can just basically do this. So this is another thing that I'm gonna do. Let's make a pattern. Here and put shadow computation, and here can place update light light or light view. Gonna place it here. I don't like the naming for this one. Shadow I can close this. Here. Find here. Shadow map. What can let me just shadow map. Yeah. That way. This. And just eat. And what we're gonna do is, instead of making two functions, and just check for our attachment. If it is of the type DLL, what I have here, app attachment, and place it here. Else, create our frame buffer. This one I'm gonna just place it 8. I don't like the way that I made it, where there is like uppercase, I hate it. But I'm just gonna change everything lowercase and use the bind here, unbind, that's from unbind. Okay, right now, so if attachment kill the attachment, this one not, if you prefer a GL or and just I was checking this height of the port be for texture, so I'm gonna change function appears to be still different. I can just place it like width, and just place it a like for height. Place it this. Okay, so right now I think this is fine. It 8 backwards. Have Okay. Other way around. Better. Okay. Now. Bind. Unbind. So now first. Okay. Like this. Oh wait. Opacity here, slide here, and activate. So no, it's here. Activate with case. This one. Now for the camera, active orthographic. Tricks. Have AP. Have. Oh. I don't know why it's not. Ah, why? Let me just name everything. I mean, let's not do that. But let's just change what I have here for. Now it's can be good practice. I have a slide here. I think it's alright now. Change every naming of case. Right now. Okay. Now just there's no problem. This because a lot of the for here instead of repeating the thing logic, we can just pass it. Right with you guys. I right with you guys. I this oh. Okay. Let me just try to animate and place function. We have interpolate, but as you can see, still need logic. So testing for a bit on how I can place this function, place this logic in all this. I call inside this function it on right. State. Yeah. This is basically just to reset. And this is a timer. The time that animation goes to start with 0 1 here where the state is right now, the start of the other state, based on that. Factor this specific hash. Let's think about this now for factoring. I think right now. So let's see. If you're curious how I made, basically when we import a mesh rigged, of course, owned, first thing that we need to take in account is the data that each bone has. So for each bone, it means that we will have vertices that is affected by that bone, given the weight. The weight meaning amount of, you can say force, or you can say how much that bone affects that vertex, meaning that the vertices close to the bone will make a will take transformation more seriously than the vertices that are not close bone. Meaning that if we have a bone, a vertex that is like distant 1 to a bone, from 0 to 1, 1 being close and 0 being far away, that vertex will take the information from that bone with the keyframe where that mesh is right now, given that position of the bone, that will affect that vertex. So let me just make this in more clear. So basically, we have a person, right? Let's say this is a bone, this is a bone, also a bone for each limb, right? And this arm, we have different vertices, right? That will make the arm. And this one, this arm has a bone, right? So meaning that this is the, let's make this the elbow, shoulder, have elbow, and we have the arm. And I'm sorry for my drawings, but this will suffice. Example. So here we have a bone. Let me make it here. Have another bone. So the vertices that are here that make the arm, right? These vertices only change position Here they are at a certain position, right? Imagine if we move this arm to the right here, meaning that this vertex should translate to here. But let's take into account that each bone has different offsets, different transformations, because this one can just come here, coming here. So here, this bone should affect only this vertex, not this one. So we should check which bone affects this vertex, and we check that given the weight, meaning how much this bone affects this vertex, how close is the vertex to this bone. And given that, we can take this matrix, which meaning that bone will have a transformation matrix, that we can apply this vertex. Of course, that vertex takes a vertex, which is the combination of a position on a given 3D coordinate for x, y, and z, and we apply that coordinate a transformation matrix, a rotation, a translation, and a scaling if needed. So that's what I'm doing here, as you can see. So first, of course, we have to traverse each bone, right? So first we have a root node, a root bone that goes from top to bottom, and we check for each node for each bone and we check for each bone for a given keyframe for each one. So imagine we start with the root. So the root will call children, and children, also the root, we have properties, and for each children that is called, it calls its other children. So it goes from parent to parent to parent, and from that we can apply that logic and implement it. So here I can explain it a lot better than this, but let's say we start with the animation, right? So for each animation we check for the node is right now from root. So let's say this is root, and we check if the name same. So this is a logic that I implemented before, where it checks from the start bottom, from top to the bottom, which node, which bone has the name root, because each bone will be assigned a name. So we check for the bone name, and each bone name will have a index. Use that index. And for that given bone, check for its keyframe. Where is it right now? Even time for searching that bone. I need some water. Be right back. If I start talking too much, my throat hurts. I'm sorry for that. As I was saying, as you can see here, this is the transformation of the bone. Get the name. We check it's 6 per second, which meaning the how much FPS that animation runs, and we get the time that from start to finish, which that's a delta time. So we can just make a condition where it just resets even the duration of the animation. So here is just a delta time, as you can see here, current animation time, where here this is for the interpolation, where we are like from jumping, we just clamp our time so it can lock our animation. So when we jump, it doesn't repeat the animation. When this fmod is like a module, is like a module operation, where even this times intake here, so if it passes duration time, resets again. So it's like a module. Here in the interpolate transformation, we get this is for the vector transformation. This is for vector, and this is quad, because sometimes we will get a types that are vectors, types that are quads. Because here we need for the rotation out. Let me continue factoring. I'm taking time here. Basically, as you can see, get the time, and even that time can get the value, and we can use that value to get our data, and we use this get a factor to lerp. This being previous is check for our index where we are now. Here we just get the value. So here, time can basically this like threshold, past that threshold, start to finish. I think for the am better uppercase, because we can identify what's my code. Yo, look, you in here? Yo, what's up, bro? I'm doing some refactoring here because I got lost on my code yesterday. And since I'm sick, this is the best I can do right now, so yeah. What's up with you? Good, good. Fortunately, since I'm doing all this, I can't show you how it is right now. But I think I have a video here that I can show you. Like, this is how the game is right now, with the shadows and all. You can slide and jump and other stuff. I made the animation click now. You mean the game that you showed me last time? Well, for the particles, it's a bit convoluted, but I did this. Like, I just created a set of quads, and what I did was just check based on the direction of them. So imagine like this. I have a set of quads placed on top of me, and they fall randomly. And when they fall, each one has a image attached to it, and given it's applied a billboard, so it will always face to me. When it reaches the ground, it use another sprite and starts a animation. So this is the logic for it. So we compute the height. So based on the camera where I am at right now at the plane, and it will always check for the most close to me, and it will generate those grains. And this is the logic that I applied to it when it's first emitted and when it's updated. But yeah, this is billboarding. But not as fancy as your game, bro. Your game is just sick. I love the concept. Wait, was I talking in mute whole time? Oh my god, that's a bit. Damn, bro, I explained the whole thing and I was muted. My god. Oh well. Yes, we learned. Yes, we learned. So, after I change the naming, I think I'm gonna change how the engine work, because as you can see, the engine itself is correlated inside the game, so I need to segregate it. So where the engine works alone, then I can only like render the game sorry, when I feel it, that from the perspective of not too much. Nah, bro. It's because I am, like I said, I'm sick, so I tend to mute myself when I sneeze or cough. So I forgot to unmute. That's my bad, bro. But I explained the whole thing, like the rain. It's basically like I was explaining how the animation works and how. Oh. I should look into that. How do you have any source where I can read? Because as you can see, how I structured my code is a bit convoluted, so I tend to get lost from the files, because some are for the engine and some are for the game. So yeah, I need to separate. But first, let me check if I finished it today, because giving me pain in the eye, literally. About it, like how did you say again? Package. Daily. You mean this one? The first one? Sorry. Find the video, you can send me the. Okay. But I will search it maybe tomorrow. Or the where is the tree? Okay, here it is. So everything done. Let's see the naming of the files. All uppercase. Good. And you file all the files of your engine file. That's really interesting. That's really interesting. Do you have any books for like studying engine? Like engine overall, not just learn some big tricks. My importer or what else? But any architect. Ethan Gregory. Arc. Okay. Oh, free PDF. Nice. Let's see. Structure of a building. What is a game? Class, gender. Okay. This is actually what I want. What? Bro. Oh my god. This is actually what I needed. Although I use oh not too else. Why and how? I like the aspect. Oh, you can work it. You already have bytes. Very much. Algorithm. Branding. Oh, this book have what? Line put. Oh, talks. Open. Action state machine. This guy. Oh my god. Wait, can you hear me? Hello? Look? Can you hear me well? I think it's because I wasn't talking close to my microphone. I'm sorry for that. I like the book. I will give it a try and read when I have time, but that was such a nice book. I really loved it. the concept of it. How can I make my stream not having delay? Huh? God damn. I thought you could. That sucks. Oh, let's say room. Wait. BD destruct. Fuck. Instead of making it this. Voila. Texture error wasn't initialized. I really hate Visual Studio Code, man. It's too much stuff. God. I use faster. Well, I have a Linux on a virtual machine, Debian. Bro, I'm thinking twice gonna change to Linux because I really hate Windows. I really hate Windows. Because on Linux, I can customize everything, bro. I use new Vim with like everything that I code. Mostly lazy Vim, but since I just know like the main keybinds, but I tend to work more faster with lazy Vim than with Visual Code. It's just too much stuff and it's heavy on my CPU and everything. I hate it. I really do. I do love him. Also, I need to learn a bit of CMake. I dropped it, so yeah, I need to go back. Thinking of dropping Win pretty soon. Well, yeah, I can use Nuvim on Windows, but like I said, I hate Windows. So I want to use like my tools on a distribution where I know that I will love it and I will keep using on that distribution. So on Windows, I tend to use like anything that let me like do my work and get it done. But on Linux, I really want my like everything set it up like perfectly. So yeah, I can make dual boot on Linux. That's a neat idea, but the problem is that from this PC I don't have like too much space. So like this, look, I only have 476 and I only have this left. This PC is mostly for like gaming, so I really want a laptop first, so where I can practice and code there, like did it mix. Was nice having you. See you next time, bro. Thank you, man. I appreciate it, really. Bye, bro. I'm gonna end. Thank you, one nice one.